Space, the final frontier. For decades, humanity has peered into the vast unknown, reaching further and further into the cosmos. But the exploration of space isn't just about sending astronauts up into orbit or launching probes to distant planets. Over the years, NASA has been steadily developing an impressive fleet of robotic explorers that are pushing the boundaries of space exploration even further. These machines are our eyes, our hands, and even our problem solvers in the harshest environments imaginable. And NASA's newest batch of space robots? Well, they're unlike anything we've seen before. If you've been following the news from NASA, you've probably heard some exciting new developments in the domain of space robotics, from helping astronauts on the International Space Station, ISS, to exploring the surfaces of distant planets. These robots are being designed to carry out missions that could previously only be dreamed of. Let's take a moment to appreciate how far we've come. The space robots we know today are not just simple machines. They're incredibly sophisticated, multifunctional devices designed to interact with their environments in ways that go far beyond traditional technology. We've already seen robots like NASA's Curiosity rover and Perseverance, which have given us remarkable images and data about Mars. But NASA is always innovating, creating new, more advanced robots that are capable of performing new tasks, assisting astronauts, and even making decisions based on the data they gather. These robots aren't just programmed to follow orders, they're built to be autonomous, flexible, and incredibly smart. So, who are these new robots, and what exactly are they capable of? One of the most intriguing developments in NASA's space robotics efforts is the evolution of its Robonaut program. NASA's Robonauts are humanoid robots that are designed to work alongside astronauts in space, performing tasks that are too dangerous, tedious, or complex for humans. The most famous of these robots is Robonaut 2, which was sent to the International Space Station in 2011. However, Robonaut 2 faced technical challenges and is no longer actively in use. But now, NASA is looking to upgrade the capabilities of its Robonaut program. The Robonaut 2 was designed with the ability to perform delicate tasks, like assisting with maintenance, operating equipment, and even interacting with the station's systems. It was designed to be able to use tools that astronauts use, and its human-like form makes it a perfect assistant for the cramped and zero-gravity environment of the ISS. However, the next-generation Robonauts, which are currently in development, will have even more advanced abilities. They will be equipped with artificial intelligence, AI, and machine learning capabilities, which means they can make decisions in real time, adapting to situations that weren't anticipated. These robots will be able to repair broken equipment, fetch supplies, and even help astronauts troubleshoot complex systems aboard the ISS or future deep space habitats. And, who knows, in the not-so-distant future, we might even see Robonauts assist astronauts on Mars. Next up is NASA's R5 robot, also known as the Valkyrie robot. This machine is designed to go one step further than the Robonauts. While the Robonauts are mainly intended for assistance aboard space stations or habitats, the R5 is meant for more autonomous exploration. The R5 is designed to be self-reliant and capable of surviving in harsh environments like the surface of Mars or the Moon. The R5 is a tall humanoid robot that's built to navigate the difficult terrain of distant planets. It has a full suite of sensors and cameras to help it understand and interact with its environment. This robot can traverse rocky landscapes, climb steep slopes, and even navigate through narrow passages, traits that will be essential when exploring environments that are too dangerous for humans. The R5 is also designed to work in the same way as a human astronaut. It can manipulate tools, perform complex operations, and handle delicate instruments. In future missions to the Moon, Mars, and beyond, the R5 could be used for tasks such as surveying terrain, collecting samples, and even conducting experiments in remote locations. If you're excited about these technological breakthroughs, make sure to subscribe and hit the notifications bell so you don't miss out on our future deep dives into the fascinating world of space exploration. One of NASA's most exciting new robots is the Lunar Terrain Vehicle, LTV. The LTV is designed to be used during the upcoming Artemis missions, which will return humans to the moon by 2025. This vehicle will be an essential part of the exploration of the lunar surface. The LTV is an autonomous robot that will assist astronauts as they explore the moon. It will carry supplies, act as a mobile laboratory, and even serve as a platform for scientific experiments. The LTV is designed to handle the extreme conditions of the moon, including its low gravity, high radiation levels, and the lack of atmosphere. But the LTV is more than just a utility vehicle. It's equipped with sophisticated AI that allows it to navigate the terrain autonomously. Using a combination of advanced sensors and cameras, the LTV can assess its surroundings, avoid obstacles, and chart out the best path for astronauts to follow. It can even analyze the terrain to help identify areas of interest for exploration. Imagine that astronauts land on the moon, and the LTV automatically goes to work, gathering samples, conducting experiments, and even helping with the construction of the first lunar base. Another fascinating robot is Astrobee, which is currently in use aboard the ISS. Unlike the Robonauts or the R5, Astrobee is a flying robot that can float freely around the station, conducting research and assisting astronauts. Astrobee is equipped with a series of sensors and cameras that allow it to navigate and map out the interior of the ISS. This free-flying robot can assist astronauts with tasks such as monitoring air quality, conducting experiments, and even delivering tools or materials to astronauts who are working in different parts of the station. Because it's designed to move freely in zero gravity, Astrobee can go places where astronauts can't easily reach. The most unique aspect of Astrobee is its ability to fly independently. Powered by electric fans, it can hover and move through the station, all while being controlled remotely by astronauts. It's a perfect example of how NASA is using robotics to create a more efficient and automated work environment aboard the ISS. Of course, no discussion of space robots would be complete without mentioning the famous rovers and drones that NASA uses for planetary exploration. The Perseverance rover, which is currently on Mars, has already made significant strides in understanding the Martian environment, from analyzing soil samples to recording sound on another planet. But NASA is not stopping there. They're working on enhancing their rover capabilities with drones like the Ingenuity helicopter, which made history by becoming the first powered flight on another planet. The combination of rovers and drones creates a powerful synergy that allows NASA to explore Mars in new and exciting ways. The drones provide an aerial perspective, while the rovers can navigate the ground, making it possible to explore areas that were previously out of reach. In the future, NASA plans to use even more advanced rover and drone systems to explore other celestial bodies, such as moons of Jupiter and Saturn. These robots will help gather invaluable data about our solar system and beyond, helping us understand the conditions that could support life elsewhere. So, what's next for NASA's space robots? The possibilities are endless. With advancements in artificial intelligence, machine learning, and robotics, NASA's next-generation robots will be even more autonomous, intelligent, and capable than ever before. From exploring distant planets to assisting astronauts on the Moon or Mars, these robots will be the key to humanity's continued exploration of space. As NASA's Artemis program and Mars exploration missions progress, we're eager to see how their robots will evolve. These advanced machines will not only assist astronauts, but also revolutionize how we explore the cosmos. With new technologies and AI capabilities, these robots will be crucial for tackling tasks in harsh environments, paving the way for future missions to the Moon, Mars, and beyond. As they evolve, these robots will redefine space exploration, making the dream of living and working on other planets more achievable than ever. The future of space robotics is incredibly exciting. The robots we've discussed today are revolutionizing how we explore the universe. With each new robot that NASA develops, we get one step closer to understanding the vastness of space and how we might live and work on other planets. So, as NASA continues to push the boundaries of robotics, we can't help but be amazed by what's to come. Make sure to subscribe and hit the notifications bell so you don't miss out on our future deep dives into the fascinating world of space exploration. Thanks for watching.